we left off. Step 3 of the chi-square test is to calculate your critical value. When you're doing this, the first thing you want to do is note what your significance level is. That number will be given to you in examination, so make sure you read through the whole problem. But if you decide to do an IA that is statistics-based, you'll need to choose your particular significance level. The most common ones are 1%, 5%, or 10%. Each one is associated with a different critical value. And that critical value is going to determine whether or not you accept or reject the null hypothesis. Once you figure out what your significance level is, then you need to calculate your degrees of freedom, which is this formula that you see here, number of rows minus 1, times the number of columns minus 1. And we're talking about your raw data. Again, that is your raw data, not your totals. Does everybody understand that? Okay. So, for exams, your degree of freedom will always be greater than 1. Okay, so you'll never have to worry about what's the next bullet talking about. If your degree of freedom is 1, then you'll be expected to use a Yates continuity correction to work out the chi-square value, not the formula that we used for step 2. Okay? Now, I'm not going to spend time in class going over that, but once we start talking about IAs, which we'll do at the end of this year, okay, and you decide that chi-square is something that you want to do a part of your project, and when you collect your data and things like that before you leave for the summertime, and it just so happens that you have a degree of freedom of 1, then on an individual basis, we'll talk about the Yates continuity correction, okay? But for exams, it will always be greater than 1. So for our example, what was our rows? How many rows do we have in our example?
3.
Rows.
2.
It's 2. Rows go across. So we have male and female, right? So it's going to be 2 minus 1. And then how many columns do we have? Because we have 4 different colors. We have blue, black, white, and red. So then we do that. We do 2 minus 1, 4 minus 1, and we multiply them together. What's our degree of freedom? 3. Okay? A lot of times, degree of freedom is just a write-down problem. So you really don't have to show that work. But if it says to show that degree of freedom is 3, then you would need to show this part. Make sense? Then we got to show the work, show the math. So, what does this mean? That means you have to use a chi-square distribution table that I'm handing out to you right now in order to figure out what your critical value is. On exams, this number is always given to you. Okay? Actually, I take that back. This number is sometimes given to you. Okay? But you won't have to worry about finding it necessarily. They took out this particular part of the test once they turned it over in 2014. So doing what we're about to do right now has been taken out of the examinations. So you're not going to get this table I just handed out on the day of your exam in your senior year. Okay? This number will be given to you for some of the problems. All right? This page is going on 71. Okay? It's taking up the whole page. Nothing else is going on page 71 but this. This is the chi-square distribution table. Okay? So if you decide to do an IA that involves chi-square, you're going to have to use this table. If you notice in this table, along the left side, it has DF. What do you think that stands for?
Distribution of freedom.
Degrees of freedom.
Oh.
Degrees of freedom. Okay, it goes 1 through a large number. Along the top represents your significance level. Okay? Written as a decimal. Okay? So over here on the very far right, this right here is a 0.5% significance level. The next one over is going to be a 1% significance level. Okay? So all these little numbers down here at the bottom, they're the decimal form of your significance level. All right? Next one over will be a 2.5. The next one over from that would be a 5% significance level. And then the one beside that would be a 10% significance level. Does everybody see that? So this particular table gives you your significance levels and your degrees of freedom. And basically what you do is to figure out what your critical value is, you use both pieces. You use both pieces to try to determine this. Okay? Now, I know this part is not on your paper, but just kind of want to make sure everybody can read the distribution table. So for our example, at a 1% significance level, the critical value would be what? So, looking at this table, here's your 1% significance level column. We had degrees of freedom of 3, correct? So basically what you do is you go across and you go down to see where those two meet. And so your critical value at a 1% significance level for this example would be 11.345. You see how that works? Okay. And again, I know this is not on your notes, but I just want to make sure everybody can read this. So at a 5% significance level, look at your table. A 5% significance level. What would that number be? Careful.
7.815.
7.815. Because we use degree of freedom of 3, we go to the 5% column and we see where they intersect, and it's that number right there. So our critical value would be 7.815. At a 10% significance level, look at your table. A 10% significance level, what would your value be?
6.251.
6.251. You see how it's used? And there you go. Again, for IAs, you'll have to figure out what this number is. Some of your older homework problems, too, because they are pulled from 2013 and earlier, you might have to do this as well. Okay? But I'm going to try to keep your tests and any quizzes and things like that I give you to where that number will be given to you. All right? Are there any questions about how to find the critical value? No? All right. And now the fourth step, the one that's going to tell us everything we need to know. Step 4 is you're going to compare your chi-squared count value, which is your chi-squared test statistic, with your critical value. That is key. You compare your chi-squared test statistic with your critical value. If the chi-squared is less than the critical value, then you do not reject your null hypothesis. That means you accept it. That means whatever you wrote down at the very beginning is true. Okay? Because you do not reject it, which means that you accept it, it's true. But if it's the other way, if the chi-squared test statistic is greater than the critical value, then you reject it, which means that whatever you wrote is actually not true. It's actually the opposite that's true. Okay? So, what was our chi-squared test statistic for our example that we were using? 33.8. So, if we were to compare that with, at a 5% significance level, the critical value would be 7.815. That means that the chi-squared test statistic value is greater than the critical value. And if it's greater, that means you reject your null hypothesis. Now, our null hypothesis said that color was independent of gender. So that means we would reject it. That would mean that t-shirt color is not independent of gender. So that basically means that, yeah, whatever gender you are, there is actually a preference on what color you prefer in the t-shirt, based off of the data. Based off of the data. Now, of course, you can draw many conclusions as to why that could be wrong. Many conclusions. But based off of the data you collected, it's not independent. Questions? Another way you can determine whether you accept or reject the null hypothesis is using the p-value with the significance level. P-value with the significance level. The p-value was that second line once you did the chi-squared test statistic. If the p-value is less than the significance level, then you reject the null hypothesis. But if the p-value is more than the significance level, then you do not reject it. You accept it. Yes? Sure. Now, you need to know these. There's no reference book reference to any of this. You're going to need to know which is which, okay? But you compare your p-value to your significance level and your critical value to your and your chi-square test statistic to your critical value. All right? Real quick, in your calculators, find the chi-square test statistic for our example again, okay? Find the chi-square test statistic for our example again, because what I want you to tell me is what our p-value is. We didn't write it down last time, so I want you to find it. So for our example, what is our p-value? It is 2.22 times 10 to the negative 7. Everybody sees that e to the negative 7? That e stands for scientific notation. So technically, what is this number when we actually write it out? How many zeros? You need 6 zeros and then 3 2s. Okay? That is 3 significant figures right there. Those zeros are not significant. The first significant digit is that 2. So it goes 2, 2, 2. And that value is very much smaller than 0.05, correct? So because it's less than our significance level, we are still going to reject our null hypothesis. So you can either use p-value and significance level or critical value in chi-square test statistics to determine whether or not you accept or reject. They should never contradict. If they do, you did something wrong. Okay? Questions?
Where's it tell you the significance value?
Well, in the problem, it will say it, but in this particular one, I told you that it was 5%. Yeah. Yes?
Mine, I entered them, and then it, reset back to the one for the problem of the day.
That might be just a calculator malfunction. So, do it again. All right? So just to recap on everything. To perform a chi-square test, you write your null and alternative hypothesis. Then you find your chi-square test statistic using your calculator, doing the features, right? In IAs, you actually got to do it all out by hand using the formula. Then you have to determine the p-value with your calculator, or use the critical value that's given on your exams, and then compare p-value with the significance level, chi-squared against the critical value. Okay? So, any questions? Uh-huh. The way I look at it is if I were to, the way I look at it is that one can't happen without the other. Just like time can't time is always going to happen, but how tall I grow is going to be based off of how long I'm on this earth. So time is always going to be your independent variable. And in that case, our problem of the day with the yield and the fertilizer, the fertilizer is what's affecting the yield. In this particular problem, gender, you're going to choose which color you like. It's more of kind of look at it and think of it in that, take it outside of the math problem, and then try to determine, okay, based off these two variables, which one's going to cause the other? Because yield is not going to cause the fertilizer. Okay. The fertilizer, which is what you put on the ground to create the crops to grow, is going to cause that. So fertilizer independent, yes. So then to write your null hypothesis is always your dependent variable is independent to your independent variable. That's the order one. Uh-huh.
Okay, that's because I thought the fertilizer was independent, and I was like, wait, why did we?
There we go. Get this glued down to page 70, and then open up your pod notebook because we're going to finish off the pod. We're going to answer questions B, C, and F. Great question was asked. On the chi-square distribution table, you want to leave it as the numbers that are there. Do not round them to 3 significant figures. Okay? So if the number is, say it's that number right there, the 10.645, you write 10.645. Okay? No rounding. All right, so write down your number of degrees of freedom. What was the number?
4.
It was 4. Show me that the degrees of freedom was 4. 3 minus 1? times 3 minus 1. Remember, it's your rows minus 1 times your columns minus 1. It's always based off of your raw data. So since my degree of freedom is 4 and my significance level is 1% back here, you have to write down the critical value for that test. So you go back to the table and you say, okay, degrees of freedom of 4, a significance level of 1%, and you see where the two intersect. And did you guys get 13.277?
Yes.
Awesome. 13.277. And then what's in the purple, remember we did that for our problem of the day. So we found our chi-square test statistic, our p-value. Now we need to state the conclusion for our test and justify our decision. That's like one of those where you have an R1 and an A1. You just can't say you accept or reject. You got to have the math to back it up. So who used the critical value and the chi-square test statistic? Raise your hand. Okay, put it down. Who used the p-value and the significance level? No matter which one you choose, we should end up with the same result. Okay? Now the answer, whether we accept or reject, that's the A1. But we can't get that without the math to back it up, which is the R1. Okay? So, if I compare the chi-square test statistic, which was 3.86, and the critical value, which is 13.277, is this number greater or less than the critical value? It's less than. And based off of what we talked about, if the critical value is less than, the chi-square test statistic is less than the critical value, you do not reject. Is that what you guys ended up with? So we do not reject it. So that means it's true. That means we accept it. That means whatever the null hypothesis was, we accept it. Which means that yield is independent of fertilizer. Okay? So we do not reject. You actually got to write that down.
We can't write accept.
Yes, I was going to say, or you could write accept. Question?
Actually, I did that one what you did, but if you look at the p-value,
Mm-hmm.
it says if the p-value is less than significance level, then reject it.
Correct.
So
So
how does it do that?
So let's look at that. The p-value was this, and we're comparing it with the significance level. And what's that as a decimal? 0.01. So if you look at it that way, it's actually what?
Don't reject.
You're not going to reject it because it is greater. So we get the same result no matter which one we use.
Oh, I left it as a 1.
Okay? And just to go another step a little bit further, it may ask this, but I doubt it. But for your IAs, if you do decide to do chi-squared, don't just say, oh, so we're going to, we're not going to reject it. We're going to accept it. Don't just leave it at that. Okay? Go a little bit further and say, well, that's kind of interesting because you would think that's the type of fertilizer you use, right? Agricultural people, right? It would produce more crops, right? What are some other factors that could affect rainfall? Bugs. Huh?
The animals and what they eat.
Animals.
Sunshine.
Sunshine. Heat. All these other things play factors in what could potentially make the yield grow. Make sense? Okay? So don't just stop there if you're doing an IA. Go deeper. You want to go deeper in IAs. Okay? So, there we go.